Target round number 7. So we have a container holding 9 milliliter of solution. 50% of this is a syrup. And after adding some pure water to get a 30% by its volume, and how many milliliters of the solution are in the container. So it's straightforward problems. Like we already have 50% water, right? And then I'm gonna say 50% of 9 is just 4.5 and milliliter of water, and then 4.5 of that is gonna be sugar, right? So like, but you have to be careful, especially like, this number 7, so maybe some units might be involved, but in this problem, it doesn't look like we have because it says milliliters anyway, so which is, we are kind of safe. We want to find the 30% to make that solution, right? So we already have a 4.5, and we are going to add some number of like pure water, but it will not change our syrup amount, right? So that's why we will get this guy divided by the total. So we had 9 already, and then we are going to add X milliliter of water. So now when we do so, this fraction will be 30%, which is just 3/10. And if I do cross multiplication, so you will get 3 times 9 is 27, plus 3x equals 45. And then you may just divide by 3 and then I get x alone, or you can just subtract 27 after divide by 3. And so then you can do either way. So if you do so, you will get 6 for x. So we have to be careful because this is not what we are looking. So how many milliliters of the solution are in the container after adding some water? So we already had 9 milliliters, and then we just add 6 more. So we should be getting as 15. So for this, like number 7, it's quite simple, to be honest. I guess the reason why, because the next one, the last problem, is a bit challenging to discover. So that's why we need more time on that, I guess. So let's cut that one. Here's the number 8. So we have a frog wants to hop on some of the lily pads that is within 5 by 5. And the frog can hop in a straight line to the center of another lily pad. However, that since the frog is getting tired, then she jumps so that each hop after the first must be shorter than the previous one. So which means the next one is the smaller than the previous one. And furthermore, the frog isn't allowed to visit any lily pad more than once. One possible pad is given after like 6, I guess, visit. And we want to find the largest number of lily pad actually that frog can visit during this sequence of hops. Okay, so be careful. We are not looking for the number of hops, like, because how do I know that? Because this was like first spot and then hop to this point. So we just count this number as 2 because that's the first lily pad was right here. This is the second. So we are looking for the number of lily pads that she's gonna visit instead of number of hops. Okay, so be mindful. And what we want to do, actually, let me clear these numbers a bit because we don't really need those for now. This is just an example. So if I clean these, because that they will confuse a bit as we go, as we list the numbers. So yeah, this is the case, and it might be, maybe I can delete those as well. So let me try and see if I can. So I can do, cancel these. It's not a big deal, but it does help a bit. Kind of see what's going on. Anyway, so we don't have these. Okay, so let's say this is our case, okay? And for us to get a more number of visits, we need to make sure we are trying to get as far from the previous step. So in order for us to do so, maybe I can start from this corner or this corner or this corner or that corner, and I can just like move on to another corner, like place that is far away from this each one. So if I start with this corner, I'm gonna name this is 1, the first one, then I can choose the opposite one, which is going to be the farthest away. And if you look at the distance as like just imagine this between each center is 1 unit. So from here to here, 1, 2, 3, 4 units, and then 1, 2, 3, 4. So imagine this hub will be straight path from 1 to 2. That will be like a distance of like 4 square plus 4 square, which is 32 units away from the original space, right? So from this spot. Why do I need that? Because I like to know the next one. The next one should be shorter than this one, and then it can be any number that we can have. So the second one, when you have the 4 by 4, we cannot have 4 by 4 anymore, but we can have 4 by 3. So I can have 4 square and 3 square. And if I do this, the longest path that the path the frog can hop is going to be 5 units away, or just root 25 units. So from 2, I just need to go 3 in one direction, 4 in the other direction. So that is where we need to consider, like, maybe I can choose 1, 2, 3, 4 units to the right, 1, 2, 3 units below. So that will be another like a path that frog can visit. This is the farthest away, or we could have this one as well, which doesn't make any difference. Our goal is just to get more number of visits, okay? So now we got the 4 square and 3 square, which was 25, but I can try to see what else I can do, right? So then maybe I can try 4 and 2, because that will be 16 plus 4, which is 20, and there is nothing in between 25 to 20 I can have, so that should be 4 square and 2 square. And then using this, because just, imagine there's a right triangle, and then 4 and 2 is like the legs. So that will be the hypotenuse, will be the straight path basically. And root 20 is the smaller than these ones. So we need to follow this order. I mean, getting smaller as we go. So 4 and 2, I can go like 4, like 1, 2, 3, but it doesn't work because we need to go 4. So which is why 1, 2, 3, 4, 1, 2. So that means I should have 4 as this point. So this is so far, I guess, fine. So we got these. And the next one is after root 20. We cannot get 19, but we can get 18 as 3 square and 3 square, which is going to be root 18. And then that's basically 3 by 3. So if I go like 1, 2, 3 units, right? 1, 2, 3 units below, then this will be the farthest away point we can have. That's 5 units. And then after root 18, root 17 is possible because I can get 4 square and 1 square. But even though root 17 is possible with the integer like movements in the x and y axis, if I consider that way, we need to make sure that is still possible in our remaining like spot, right? So we want to get 4 in one direction, 1 on the other direction to see if this is possible. I can go like 1 units to the left, 1, 2, 3, 4 up. So that means this is gonna be 6, which is possible. And the next one is 16. So 4 square and 0 square. And if I do this, so root 16. So only way that we can do is just 4 units all the way to this direction, which gives me 7 right there. So we got that. And the next one is after 16. We will try 15, but there's nothing like that. So we just need to square the integer, which is like 3 or 2, which is going to be 13, I guess we can achieve. So when you do 13, so I need to go 2 and 3 directions. So I can go 1, 2 units this way, 1, 2, 3, but it doesn't work this way. So I can go maybe like 1, 2, 3, 1, 2. So that might be another spot we can get, which is possible. And then we got 8 already. And if I want to continue in this kind of process, I'm going to get at the end what I wanted. So which is now maybe try and find the 12, but there is nothing like that. We can do 10 best as 3 square and 1 square. And that is root 10. Okay, so if this is the case, we can get 3 and 1, which we need to check if this is possible. So if I go like 1 unit up, 1, 2, 3 units to the left. So that is actually possible. This is going to be 9. And now after this, we can get 9. So 3 squared and 0 squared. So we just need only basically 3 units. So I can just go 1, 2, 3 this direction, or 1, 2, 3 this direction. So I think either way should be okay. So I'm going to try this one, which is going to be 10. As soon as we have this, now we do need 8. So 8 is possible, 2 square and 2 square. And that will be root 8. We just need 2 by 2. So I can go with 1, 2, 1, 2. So that should be 11. So that is possible. And now root 7. But I feel like we cannot get root 7 or 6 square and those integers. So, but root, I guess 5 is possible. So we can get 2 square and 1 square, which is root 5. So we just need 2 by 1 from the 11. So I can go like 1, 2, and 1. I can get here, or 1, 1, 2, which could be right here as well. So either one is okay. So I'm going to go with this is 12. And now we want to get root 4, which is 2 squared and 0 squared. And this is going to be root 4. So I need 2 unit movement basically. So like after 10, we just need, actually, let me see if this is, yeah, actually we had 11, not 10. So this was 11, so I need to move 2 units away from 11. Maybe, did I miss anything? Let me double check. We got, I mean, 12 is our last move. Okay, this was the last move. I was kind of confused. So this is 12. I need to move 2 units from this 1, 2. I can go with here, which is going to be 13 movements. And now we have, the next one is like 2 doesn't work anymore. So we are going to do 1 square and 1 square, which is going to be 1 by 1 moves, root 2 units away from this guy. So I can get to this point, or I can get to this point. I'm going to go with this guy to be 14. And then as soon as we can only have 1 square and 0 square, because we have to get smaller than the previous one. So that's root 1. And it could be anywhere. I can have now here, here, or there. So there is no real difference. If I want to go with 15, this one, and then there is no movement because that will be just 0 by 0. That's the 15. So, you know, it took a bit longer. And then if you do kind of some small mistakes on the kind of counting, or like missing those some of the like square root numbers, that is achievable, then you might be up by 1 or 2 and stuff. So which is why it's kind of tricky. And also if there was like 6 by 6 grid or 7 by 7 grid, that might be a bit challenging as well. So there is a bit better than this approach, to be honest, which is you may find even a formula for this. And I'm gonna kind of leave a challenge for you to find the formula. But let's say if you have only 1 by 1, like if there is only 1 by 1, let's say this is only one as the lily pad possible, then the frog can have only 1 like visit, which is going to be 1. If there is like 2 by 2, which is usually we know we start with some basic cases and find a pattern. If this is the case, then our first move could be one of these corners, and then to get the longer movement, so we can get this is 2. And then after this, this could be, or this could be another move, which is only 3 ways at most possible. But if there is like 3 by 3, okay, let's see if we can get something nice relation. So like if I start with 1, that will be 2. And then since we know what to do as of now, so then the next one could be like maybe here. So 3, which is 1 by 2, which is like root 5. And root 4 is like, is the next one, which could be 2 by 0, which is going to be here. So that's 4. And then as soon as we have this one, that's 2 moves, like root 4. So I can get 1 by 1. So I can have here or there. So if I go here as 5, so that was my next move. And if I want to now do last move as 1 unit, so it could be here or it could be there. So let's say this is 6. So I hope that was clear after this long one. So that is 6. So we already know 1 by 1, 2 by 2, 3 by 3. Maybe if we can achieve 4 by 4, then we can get 5 by 5, even 6 by 6 by some pattern. So here's what I'm gonna kind of tell you. If this is 1, this is 3 at most, and this is 6. And whenever you have a bunch of numbers, and then if you really expect a pattern, maybe it's good to find their difference, which is going to be 2. And the difference between these two is 3. And I'm hoping the difference between this one and the next one is going to be 4, because this is just one more. And that will be like 4. If this is 4, so the next number should be 10. The numbers are increasing every time by one higher than previous one. So the next one has to be like, this is 4 more. This has to be, next one is 5 more. And if you look at the difference, that is equal to 5. And we call these numbers as the first difference. If you take the second difference, you will get 1, the 1 and 1. And I just say this is like, I'm hoping to get 10. If you kind of are not convinced, you can make a 4 by 4. I just didn't want to do that. And then you can actually count those 10, which is not going to be too challenging after 15 that we just did. So you are going to see this one. As soon as you have 1, 3, 6, and 10, then the difference is actually just increasing by 1 every time. And then you can get this immediately. If I ask you what would be 6 by 6, then I wouldn't really try our first approach, maybe finding some pattern like this. And as soon as this is the case, we can just increase this by 6. That will be 21. So that would be our answer. And then I'm going to ask you to kind of challenge yourself to create an expression to give us any number of grades. Okay, so by using this one, and then if some of you may have some formula as well, but I'm going to leave this part for you as extra challenge. Okay, I'll see you in the next video.